So this was the question that we were discussing earlier. The position vectors of P and Q are given as A and B. If R is a point on PQ, okay, so let's consider this as PQ. R is a point on PQ such that PR is equals to 5 of PQ. Okay, R is a point on PQ such that PR is 5 times of PQ. Then we have to find out the position vectors of R. Actually, the question there's a mistake in the question, but if we do not consider it, like if we do not think practically that how PR can be 5 times of PQ and R can still be existing on PQ, then we can find out its solution. So as you know, P, even if we like consider R on not this straight line but somewhere else, so P's position vector is A, Q's position vector is B, R's position vector is that we need to find out. Let us assume it as C vector. What is given? PR vector is equals to 5 times of PQ vector. So we know how do we find out the position vectors? By subtracting. Okay. What is R factor? It is C factor minus P is what? A factor. Is equals to 5 into Q B factor minus A factor. C factor minus A factor. Sorry. C vector minus A vector is equals to 5 B vector minus 5 of A vector. We need to find out C. So let's keep the C vector on the left hand side and everything else on the right hand side. That makes it 5B vector minus 4A vector. So that means A is our correct answer. Is this clear?
Yes, sir.
This is the sectional formula, inner division, external division. Any doubts in understanding these? Yes. Should I repeat? Should I repeat?
No, sir.
Okay. AB, mostly the confusion is there in the external division and in the ratio part. So consider AB is M and EP is N. Okay. So what a simple vector in orthogonal form looks like. Okay, so this is a vector. Let me draw this vector in a plane. Okay, there's a point P having coordinate EPC, and there's this vector. Okay, now let's discuss about the features of this vector. This vector is making, as we know this is x-axis, this is y-axis, and this is z-axis. So this vector is making alpha degrees with the x-axis and beta degrees with the y-axis and gamma angle with the z-axis. Now we know this distance is x and this distance is the magnitude of this vector. So we have the hypotenuse in the base, so we can find out the cos. So cosine of alpha is what? Base upon hypotenuse, which is actually square root of a square plus b square plus c square. And oh, sorry, this is not x, this is not a, this is not x, this is a distance, because we are going to take x coordinate, so that's why I mistakenly written x here. This is a here. Okay, so cosine of alpha will be this. Cosine of beta, similarly, this distance will be b. Cosine of beta will be b by modulus of a. Cosine of gamma will be c by modulus of a. Great. If we were to find out the unit vector, then it would be also a by modulus of a I cap plus b by modulus of a j cap plus c by modulus of a k cap. These, if we see, are cosine of alpha, cosine of beta, cosine of gamma. And there's a new term that I'm introducing, direction cosines. These are known as direction cosines. Or we may call it the coefficients in the unit vector are the direction cosines, and the coefficients in the parent vector are direction ratios. We'll talk more about them in 3D chapter. But you have to know, you have to understand the concept of how do we have find it out the alpha, beta, gamma, which are the respective angles that the vector is making with x, y, and z axis. Are there any questions?
No, sir.
Okay. So let's rewrite. Modulus of a was a square plus b square plus c square. Cosine of beta, b divided by a square plus b square plus c square. Square root cosine of gamma, c divided by a square plus b square plus c square. If we were to square them all and add cosine of square alpha plus cosine of square of beta plus cosine square of gamma, then it will become a square, as the denominator is same. So taking LCM, and as also we have taken their square, so square root is cancelled. A square plus b square plus c square. Numerator cancels denominator, comes out as 1. So cosine square plus cos square beta plus cos square gamma is equals to 1. Clear?
Yes, sir.
Okay, so we were talking about scalar product earlier in the class. Now let's talk about projection of vectors. Let me say that this is a vector and this is another vector. This is a vector and this is b vector. If I project a vector on b, let me say the angle between them is theta. Then this much angle, this angle till here is known as the projection of vector A on vector B. And it will be given by, as we know, that this is the base. So cosine theta is equals to base vector that we need to find out divided by the hypotenuse vector. So the base vector comes out as, A into cosine of theta. So A vector cosine theta is the projection. The projection of vector A on B is A cos theta. Any doubts? Yes or no?
Yes, sir.
So are there any doubts?
No, sir.
You said yes, sir. Okay. So A into cosine of theta. How can we find out cosine of theta? We can find out by, we knew A dot B was right. Wait a second. Are we doing any mistake? Yes or no? No, I guess no. Hmm. So this A vector, let me revise things. So this was the hypotenuse vector. Okay. Hypotenuse divided by the base is equals to cosine of theta, where these are sides, not vectors. So the hypotenuse vector side is a magnitude divided by the base vector's magnitude. So the base vector's magnitude is equals to cosine of theta. So the base vector's magnitude will be what? Will be more, will be, I have written it like ulta pulta लिख दिया मैंने सब. Cosine theta is base upon hypotenuse. Let me rewrite. So what is cos? Cos is actually base upon hypotenuse. Pandit Badri Prasad upon Har Har Bole. So Badri Prasad, Badri and Har Har. So cosine theta into hypotenuse, which is actually A modulus, is equals to the base vectors modulus. So its magnitude is this. We only have the magnitude. That is what we are finding out here. Is this clear now? Yes or no?
Yes, sir. Clear, sir.
Okay. So it's magnitude that we are taking. Okay. So the formula for this comes out as projection of vector O and B is A dot B. You simply take the dot product and divide it by the magnitude. Divided by the magnitude. So let me revise in the new page. That if there are two vectors, I'm just writing the formula now, not the concept. A vector and this is B vector, theta angle. If we are finding out the projection of vector A on B, then we'll take the dot product and the divided by the vector's magnitude here. Like what is the on which we are finding out. So B is vector magnitude. If we are finding out the projection of vector B on A, then we'll take the dot product simply A dot B divided by modulus of A this time. So whatever simply is here. This is the trick to remember. Understood?
Yes, sir.
Okay. Talking about the scalar product more. If there is a vector given A1 I cap plus A2 j cap plus A3 k cap, and then A vector dot I cap will be equal to the coefficient of I even. Similarly, A vector dot j cap will be the coefficient of j cap. A vector dot k cap will be coefficient of A3. Why? Because if we are taking a dot product with I cap, it means that 1 I cap plus 0 j cap plus 0 k cap. So 1 into A1 becomes A1 plus A2 into 0 becomes 0. A3 into 0 becomes 0. So only A1 is left. Is that clear? That clear? Yes or no?
Yes, sir.
Okay. Next property. So whenever we are talking about dot product, we know the formula is this. So it's max, it will be maximum when cos theta is maximum, and that will be when theta is 0, when angle and vectors are parallel. It will be minimum when theta is 90 degrees. It will be minimum, or should I say like null? I should say null, because minimum will be something else. That will be null or 0 when vectors are perpendicular. It will be minimum when theta is 180 degrees, like anti-parallel, anti-parallel, unlike vectors. So this is all about the dot product. Let's now discuss some examples. Please stop me whenever you have any questions, okay? Is that okay, Yarini?
Yes, sir.
It's a very good example, and using it, we can understand vectors very well. Okay. We need to find out the value of P, for which like there are two vectors given. Let's consider the first scenario when the vectors are perpendicular. So if two vectors are perpendicular, the dot product will definitely be 0. So let's take the dot product of A vector and B vector. So how do we find out when we have the vectors? So 3 into 1, 2 into P plus 9 into 3, 27 makes it 0. 2P becomes minus of 27 plus 3, 30 minus 30. So P becomes minus of 50. In the second case, when vectors are parallel, they has to be following a certain pattern. It means that their coefficients will be proportionate. 3 by 1 should be equals to 2 by P should be equals to 9 by 3. So 3 is a 9. That's same. So let's take this one equality. So 2 by P is equals to 3. That gives us P as 2 by 3. So these are two values of P. Ask if there are any questions. Go ahead. The next question says, if A vector plus B vector plus C vector is equals to 0 vector, and A's magnitude is given as 3, B's magnitude is given as 5, and C's magnitude is given as 7, then find the angle between A and B. Yeah, sorry for inconvenience. So that it's our question. Let's find the solution. So in the question, it is given that the sum of three vectors is 0 vector, and there is magnitude given of all three vectors, and we need to find out the angle between A and B. So we need to tweak this question as per our convenience, so that we'll have A and B on one side and C on the other. So A vector plus B vector can be written as minus of C vector. Let's take it square. On squaring both sides, minus minus becomes plus. Let's say A vector square is A magnitude square plus B is magnitude square plus 2 into A dot B. C vector square means C magnitude square. Magnitudes are given. So this becomes 9 plus 25 plus 2 into magnitude of A, that is 3, into magnitude of 5 into cosine of theta. Theta is the angle between A and B. Magnitude of C is 7, so this becomes 49. 925 becomes 34. 34 minus 49 becomes 15, I guess. Right. So 2 into 3 into 5. Yes, 2 into 3 into 5. 6 into 5, 30 cosine of theta. 30 cancels 15 by 1 by 2. Cosine theta becomes 1 by 2. So the angle comes out as 60 degrees because cosine is 6. Cosine 60 is half. So the angle is 60 degrees. There's a similar interesting question. For which the angle between the vectors A is 2x square plus 4xj cap plus k cap and B vector was to 7 I cap minus 2j cap plus xk cap is obtuse. So we know what is an obtuse angle. Obtuse angle is the angle lying between 90 to 180 degrees. So we have both of the angles, both of the vectors. Only one thing is there, which is unique. That is the x, the variable. So how do we find out the angle? By taking the dot product, dividing by their magnitude, right? So one thing that is very sure that theta is lying between 90 and 180. Okay. Now, when theta is lying between 90 and 180, we know cosine theta is negative because theta is lying in 90 to 180 degree means in the second quadrant and cosine theta is negative here. So if cosine theta is negative, we know this can never be negative, this can never be negative. So this numerator, this entity has to be negative. Okay, if that is so, then A dot B should be negative. Now we do know about A dot B and let's find out what is the dot product. So the dot product will be 2x square into 7, 14x square, 4x into minus 8, minus 2, so minus 8x, plus 1 plus x less than 0. Now we have an inequality where we have single variable. We can find it out. Very easy for us. Yes. So 14x square minus 7x should be less than 0. Writing it here. Taking 7x common. So 2x minus 1 should be less than 0. So either x is less than 0. So first let's find out the critical values. How do we find out the critical values? By equating first. So either x for which this entire equation will become the entire expression on the left hand side will become 0. So this is what the critical value is. So x is equals to 0 and x is equals to half. Positive infinity and negative infinity. We have talked about this method earlier. This will be always positive when the coefficient of x is positive. So the entire expression will be positive for all value greater than half. All values greater than 0 and less than half will be negative. This will be positive here. What do we have to find out? For all the values of, we have to find out the values of x for which the expression is negative. So the x value should lie between 0, 0 excluded, and half. So this is our answer. Any questions?
No, sir.
Okay, then that's much about the scalar product. Let's now move ahead and discuss the cross multiplication of vectors. Or we call it vector product. This is represented by A vector cross B vector and is given by A vector's magnitude into B vector's magnitude into sine theta this time, along with the unit vector. So, along with the unit vector. This is just the magnitude. This is the direction of this vector. Because we know the resultant of cross vector or the vector product is a vector quantity. It's a vector quantity. So it will give us a direction also. Now first let's discuss about how this direction is calculated. Please understand this concept really well. So first let's consider there is a plane. There is a plane. There is a plane. And on this plane, there are two vectors. Let me call it a vector A here. And there is another vector here. This vector is A, this vector is B. The angle between these vectors is theta. When I cross multiply A vector and B vector, then it gives me a vector just perpendicular to both of these two vectors. So if the resultant vector is perpendicular to both of these vectors lying on a plane, so the resultant vector will also be perpendicular to the plane. So the resultant vector should be perpendicular like this. This is the resultant vector, A vector cross B vector. Now there were two options for me to draw the resultant vector. I could have also drawn the resultant vector perpendicular to the plane downwards the plane. Yes, that is also a contingency, but that is a contingency of A cross, I should write B vector cross A vector. Now there is a question, there must be a question inside your head. Is A vector cross B and B vector cross A are different? The answer to that question is yes, they are different. Cross multiplication of vectors is not commutative in nature. So how do we really define it? Whether the resultant vector is upwards or downwards? We will define it by using a law, a particular rule. And that rule's name is right-handed screw system or right-hand thumb rule as we call it in physics. So if we are going from, if we are calculating about A vector cross B vector, so what we have to do simply, we have to cross our fingers from the first vector A to the B vector in so that our fingers go and cover a acute angle kind of thing. Acute angle, not like if you are going from A to B, we'll go this way, not this way, this big way. We'll try to follow an acute manner. So we have this is our thumb And these are our fingers going from A to B. I hope my drawing is good. A cross B. Okay, when we have to go B cross A, then we'll B cross A will go like this. So our thumb will naturally of the right hand will point downwards. As this time it is pointing upwards. A cross B. For B cross A, it will be downwards. Any questions? Key points to write is A vector cross B vector. We call it as C vector or whatever. This resultant vector is always perpendicular to both A and B vectors. And second other thing to consider is that we use right hand thumb rule to estimate the direction. Third important point is the cross multiplication of A and B is not commutative, means it will not be equal to B cross A. It's not commutative. What other properties are there? Is that this is associative and distributive. There's no problem in that. Associative means if M vector M into A vector crossing with B vector is equals to A vector crossing with MB vector. Or we may call it as M into A cross B vector. M is a scalar here, remember. This is also distributive. Distributive means that A cross B vector plus C vector. This is just to remember these, na? Distributive and associative. So distributive means that it will distribute itself. This is distributive property. Okay. Let's go back to the formula sine theta. So this time parallel vectors, the cross product when theta is 0 degrees, when vectors are parallel, then their cross multiplication vector is going to become 0, null. Okay. When theta will be 90, there will be maximum. Okay, that's one important thing to understand. So similarly, let's talk about the most famous vectors that we know, I cap, j cap, and k cap. So as we know, I and I both are same vector, so they will be collinear. Hence, if they are collinear, they will be making 0 degree angle in between them. So I cap into I cap will be 0. Similarly, j cap into j cap will be 0. K vector, k cap cross k cap will be 0. An interesting thing is this, that this time I cap cross j cap will be equals to k cap. Why? Why? Because x, y, and if we take a cross multiplication, that comes out as perpendicularly outward, that is z. So that is how. So as we know, I cap cross j cap It's not going to be commutative. So j cap cross I cap will be minus of k cap. Now there is a pattern to remember it. So there's this trick. You write I, j, k in this manner, in clockwise manner, and depict the clock. So if you're going to do the cross multiplication in the clockwise manner, then the resultant will be positive. I cross j will be positive k. J cross k will be positive I. And k cross I will be positive j. I cross j, as told earlier, will be positive k cap. If you have taken otherwise, then they will be negative, like in this case. So this is important about vector multiplication. But how do we exactly find out the vector multiplication when we have two exact vectors using this formula? Yes, we can use this formula, of course. But when we have magnitude, when we have the magnitude of both, when we have the angle, and we have the unit vector direction, the unit vector of the resultant vector. What we have, if we have the exact vectors, let's say vector A is given as A1 I cap plus A2 j cap plus A3 k cap, and B vector is B1 I cap plus B2 j cap plus B3 k cap. We have to find out the cross vector multiplication. Just draw a matrix of 3 by 3 order. Write I, j, k cap in the first row and the coefficients of the first vector here. Then the coefficient of the second vector here, and simply solve the matrix. That will be our resultant vector. Simple as that. There are some applications of cross multiplication vector as well. What are the applications? If we have in triangles. So if there's a triangle and we have the two vectors in it. This is the triangle. And we have these two vectors, A vector, B vector. Then we can find out the area of this triangle. A, B, C. Okay. So we can find out the area of this triangle. How? By taking the magnitude, the cross multiplication of these two vectors. Simply, this will give us the area. And we have an application in parallelogram as well. So if we have two vectors in the parallelogram, then simply the area of parallelogram will be magnitude of the cross multiplication. Simply we have doubled the area of the triangle, right? That's the area of parallelogram. There's one more application. We have a parallelogram, and in this parallelogram, we have the vectors of the diagonals. The vectors of the diagonals. Then also we can find out d1 vector, d2 vector. Then the area of parallelogram can also be found out by taking the cross multiplication of this vectors, its magnitude, and its half. That's the area of parallelogram. If we have the vectors of the two diagonals. Revise, please. Done. Any questions?
No, sir.
So there's a question. We have to find a vector of magnitude 9, which is perpendicular to both the vectors. For I cap minus j cap plus 3k cap and minus 2 I cap plus j cap minus 2k cap. This is the question. So what do we have? We have two vectors and we need to find out a vector which is perpendicular to these both of these vectors, and the vector should be of magnitude 9. Okay, so if we find out the let me call this vector as a vector, and then let me call this vector as b vector. So if I find out a vector cross b vector, so that a resultant vector will definitely be perpendicular to both of these vectors. Okay, but we need to find out a vector of magnitude 9. Okay, so what if I take the direction only from the cross multiplication? Like, let me call A cross B vector. Let me save this file first. So that is for sure that if we take the cross multiplication of two vectors, the resultant vector will be perpendicular to both of those vectors. So from the result, let's just use its direction. How do we use the direction? Like the C vector, its direction will be C cap. This is a unit vector. This is a unit vector. Now, this will only have direction. And this is going to be perpendicular to A vector and perpendicular to B vector as well. Yes or no? Is this thing clear?
Yes, sir. Clear, sir.
And we have to find a vector. Let's call it as X vector. So X vector should have 9 as its magnitude, and its direction, we can take it from C vector. Cool. Because in a vector, there is a magnitude, and in the direction we are taking it from the calculation, and magnitude is given to us. So how do we find out the C cap? C cap will be find it out by uh, C vector divided by C vector's magnitude. C vector is A cross B divided by A cross B vector's magnitude. Okay, first let's find out A cross B. Determinant I cap, J cap, K cap. What it is given? 4 minus 1 and plus 3. 4 minus 1 plus 3 and minus 2 plus 1 and minus 2. Okay, I cap minus 1 minus 2 plus 2 minus 3 into 1 3 minus of j cap 4 minus 2 minus 8 minus 3 into minus 2 plus 6 minus k cap, sorry, plus k cap 4 into 1 4 minus into minus 1 minus 2 plus 2. Okay, so that becomes minus of I cap minus 2 minus minus plus minus plus 2j cap plus 2k cap. That is A cross B vector. Let's find out its. So we were calling this vector as C. Let's find out its magnitude. That will be, so minus 1 whole square 1 plus 2 whole square 4 2 square 4. So 4 4 8 8 1 9. So magnitude comes out as 3. The magnitude comes out as plus minus 3. Okay. Or magnitude is always positive. So let's call this as plus 3 only. Magnitude is 3. Vector C is this. Now, the direction. C vector upon C vector is magnitude, which is 3. C vector is minus of I cap plus 2j cap plus 2k cap, as we have found it out. Yes, it is so. Now the x factor that we need to find out. Now there is one thing to remember, is that x factor can be 2. C unit vector is also giving us, let's say, this is A vector, this is B vector, and C unit vector is giving us this direction. This is perpendicular, but this is also perpendicular, na? Okay, so we can take plus minus here because we do not care about upper or lower. We just care about that it has to be perpendicular and its magnitude should be 9. So that's why we are taking a plus minus sign. Is that clear? Yes or no? Clear or no? Should I repeat?
So, clear, sir.
Okay. Then plus minus 9 into minus 5 plus 2 j cap plus 2 k cap divided by 3. 3 cancels 9 by 3. So this becomes plus minus minus 3 minus 3 I cap plus 6 j cap plus 6 k cap. Our answer. See how smartly we have used the direction from the cross product and the magnitude was given to us. Let's move to the next question. Determine a unit vector perpendicular to the plane defined by the vectors. A vector is 2 I cap minus 6 j cap minus 3 k cap. And B vector is 4 I cap plus 3j cap minus 3k cap. So this is our question. This is our question where we have to determine a unit vector which is perpendicular to the plane defined by these vectors. Okay. So plane defined by these vector means that A vector is this and B vector is this, and the plane is in between these two vectors. And we have to find a unit vector which is perpendicular to the plane. So it can be perpendicular here or here. Okay. And we can find it out by finding the cross product between these two vectors which are defining the plane. Okay, so we will do simply cross multiplication and division by their magnitude. And plus minus also will be considered this time too. So let's find out the, let me call it as C, the cross multiplication. Plus 2 minus 6 minus 3, 4, 3 minus 3. Okay, I cap into minus 6 minus 3, 18, minus minus plus 9, minus j cap, minus 6 plus 12 plus k cap 6 plus 24. 18, 9, 27. I hope we are doing it rightly. Yes, we are doing it correctly. 27 I cap plus 6 minus minus 6 j cap 24 6 30 k cap divided. Okay, not divided. This is the only answer. Okay, so this is C vector. What let's find out its magnitude. So 27 square, okay, plus 6 square plus 30 square. So we can do one thing. Instead of finding out this much, we can take common something. We can take 3 common from everything, from every term. So if we are taking 3 common, so 3 square will be taken common x3. So 3, this becomes 9 square, this becomes 2 square, this becomes 10 square. Now this is much solvable. 3 whole square will come out as 3 only, square root 81 plus 4 plus 100. This comes out as 3 into 185. Okay. So the A dot A cross B cross upon A cross B cross magnitude. This will become 27 I cap minus 6 j cap plus 30 k cap, right? 30 k cap divided by 3 into square root of 185. 3 cancels this by 9 I cap minus 2 j cap plus 10 k cap. That becomes our answer. 9 I cap minus 2 j cap plus 10 k cap divided by 185 square root. This is our answer. Square root of 185 in the denominator. Let's now move ahead. For any three vectors. So this is our question. We have to prove this. Okay. So we know distributive and associative property. We'll use it. A cross B plus A cross C plus B cross C plus B cross A plus C cross A plus C cross B is equals to 0. Sorry, that's what we need to show. So what we can observe here, the pattern, similar terms. And we know that A cross B is not equals to B cross A because that's not commutative. But we know this, that A cross B is equals to minus of B cross A. And if that is so, this cancels this. Sorry, this cancels this. Similarly, this cancels this. This cancels this. Right? So the result 0. Hence proved. Any questions, doubts?
No, sir.
Okay. How much are you enjoying this chapter? Vectors.
Uh, Not so much, but it's better. Okay, sir.
It's better. Okay. Okay, great. So we
Because
have
I
been
hate these vectors in physics. That's why.
okay. What do you think? What's wrong with vectors?
No, sir, it's not easy. Like, for me, I feel that it's not easy like other chapters. That's why.
Yeah. I have found it out that whenever I found any chapter difficult, and if I just pushed a little, pushed myself a little more in the starting of the chapter, then the whole chapter becomes easy. So it's very important for us to understand the basics. So if you have a difficulty, you can watch the lecture once again and clarify and strengthen your basic. Okay.
Yes, sir.
So let's now discuss about STP. STP. Can you guess what STP stands for?
What STP?
What STP stands for?
Is it in chemistry or like? No, in chemistry we used to like say that it has standard temperature and pressure, sir.
Very good. And what is that? What is standard temperature and pressure? How much kelvins, how much bars?
Means according to temperature we say 0 degrees Celsius.
Okay. STP, actually, I don't know that much chemistry that you might be knowing, but according to my little what I know is that STP stands for as condition where like temperature is certain zero, yeah, 273 Kelvins and pressure is of 1 bar. So there are like certain parameters that are fixed and we compare them with with the chemistry or with the lab environment, and then we call it as per STP or something like that. So we try to maintain same temperature and pressure while doing experiments and while drawing results. So STP, but here not stands for standard temperature and pressure. It stands for scalar triple product. Earlier, we were discussing about the product of vectors, but only two. This time, triple product suggests us that we are discussing about the product of three vectors. And when there is scalar written as well, so we might assume it very well that the outcome of the product is going to become a scalar quantity. Yanni, can you tell me what is the difference between a scalar quantity and a vector quantity? In just one word.
Yes, like actually scalar only depends on magnitude, but vector quantity actually depends on both magnitude and direction.
Very good. So it's the scalar triple product is going to give us a scalar quantity which will not be dependent on the direction. So it is also known as a box product. So as we know that there will be three vectors, and if we box them, this is representing a scalar triple product. That's hard to understand. Actually, what we'll be doing here actually is that A vector is getting scalar multiplied with the cross multiplication of B vector and C vector. So how can we write it? Like, let's say we are following the same procedure. A1 I cap plus A2 J cap K cap. And similarly, B, C for everyone. Okay. So let me write them. Okay. So A vector A1 I cap plus A2 J cap is A3 K cap dot product with cross multiplication. We know the formula. B vector, so B1, B2, B3 to C1, C2, C3. Okay. So we know this is getting multiplied with this. So we know about the properties of determinant. So if there is any scalar outside and if there is any scalar getting multiplied, we can take it common from any row. We could have written it outside the determinant. So let's now bring the outside element inside in the first row. So what we'll be doing, we'll be multiplying this in the first row. So A1 I cap into I cap, this whole vector into I cap, it will become A1 only. We have discussed about this property earlier as well. So this will become, let me save it. So the first row will become A1, A2, and A3. Why? Why? Because of the dot multiplication. So simply consider it like A1 I cap plus A2 J cap plus A3 K cap is getting dot multiplied, scalar multiplication with I cap plus J cap plus K cap. So this will become A1, A2, A3, B1, B2, B3, C1, C2, C3. This is simply STP that we call it. A vector, B vector, C vector, which is actually dot multiplication of A, the cross multiplication of B and C. So this is just all that is, it is an explanation, but what is important here is this. This is the box product. This is important. This is the result. These are just manifestations. Any doubt? Scalar triple product?
No, sir.
Okay, great. So as this is a determinant, so all the properties that are applicable on determinants will also be applicable here. Just for few examples, I'm writing few examples. L and M are scalars here. So we can take common L from the first column and L from the third column as well. So it will become L square and M from the second column. Another example. Can be written as the sum A, C, D and B, C, D. A plus B. It can be split in the sum of two determinants. The cyclical exchange of rows. If I don't do it cyclically, then minus sign will be there. These are some properties. All the properties of determinant will be applicable. Remember, this is representing the whole column. This is representing the whole column. Sorry, actually the whole row. A is the first row, B vector is the second row, C vector is the third. There are some applications of this as well. First is for the paralleloid. Actually a cuboid. Let me draw it. This is a cuboid, but parallelepiped will be, except then squares or rectangulars, there will be parallelograms. Yes. So when we need to find out the volume of this parallelopipe, so actually it is made of like cuboid is made of LBH, 3 dimensions. So it will also have 3 vectors. A vector, B vector, and C. And the volume will be given by A vector, B vector, C vector, scalar triple product. And for tetrahedral as well. Tetrahedral is as well. The volume for tetrahedron can also be given by this. So here, as we call it, that let me show you the diagram of tetrahedron first. Let me do it. See, we consider this as O, this is A, B, and C. So OA vector as A vector and OB vector as B vector, OC vector as C vector. Then here, remember OA vector is A vector, OB vector is B vector, OC vector is C vector. The volume of tetrahedron will be 1 by 6 into the box. And of course, volume can never be negative. So why not taking a screenshot and applying this in our notes? This is the concept of tetrahedral or tetrahedron, whatever we call it. Remember, OA is the A vector. Volume will be given by 1 by 6 into the Boltzmann STP, scalar triple product. Let's take an example. We have to find volume of parallelopiped. Both sides are given by minus 3 I cap plus 7 j cap plus 5 k cap and minus 5 I cap plus 7 j cap minus 3 k cap and 7 I cap minus 5 j cap minus 3 k cap. Okay, so we know STP determinant minus 3, 7, 5, minus 5, 7, minus 3, 7, minus 5, and minus 3. Minus 3 into 7 minus 3, minus 21, minus 5, 3, 15, minus of 7 to 5, 3, 15, minus plus 21 plus 5 into 25 minus 49. Minus plus, everything is plus. 21, 15 makes it as 36. 36 into 3, 108. This makes it as 36 as well. Okay, great. So actually we can take 36 common here. Smart work. Let's do some smart work. 36 common. plus 3 minus 7. Okay. Plus 5 into, what is this? Minus of 24. Minus of 24. This makes it as 36 into minus of 4 plus 5 into minus of 24. We can do smart work here as well by taking minus of 24 common. So 36 into minus 4 divided by minus 24 because we have taken it common, plus 5. Minus minus cancels. 4 into 24, 6. And 6 is 36. 6 5 becomes minus 24 into 6 5 is 11. This is our answer. And minus, the volume cannot be minus, so it will be 1 plus 24 into 24, 264 cubic units. Cubic units will be our answer. 264 cubic units. Now see how smartly we have handled the calculation part, right? Any questions? No questions?
No, sir, no questions.
Okay, so continuing our STP, let's write some more properties. So three vectors will be coplanar when the STP is 0. Then they will be coplanar. Or this is like this is basically the condition. Also, any of two vectors out of A, B, C are collinear. For this state also, this is the condition. If this condition is staying true, that means that three vectors will be coplanar. Any two of those vectors are collinear. Collinear means parallel. Next property. A to A, B is equals to 0. Or we can write it as is 0 first. Why? Why 0? Let's understand. It means that A vector dot product with 2A cross B. We can take 2 out. 2A. So let's bring the 2 out of the picture, right? So 2A dot into A vector cross B vector. Now A vector cross B vector will be perpendicular to A. So if these two are perpendicular, the dot product will be 0. 2 into 0 will be 0. That is why it is 0. Clear? Any questions? Should I explain it again?
Clear, sir.
Okay. One more property is that we can write A vector minus B vector, B vector minus C vector, C vector minus A vector. Their STP will be 0. Cyclical in nature, no? That's why. Or A vector cross B vector B vector cross C vector, C vector cross A vector will be equals to STP of A, B, C vector whole square. These are direct results. Very helpful in exam. Now there is an example given vectors are A minus 2I plus 4j cap minus 2k cap. B vector as 4I cap minus 2j cap minus 2k cap. And C vector minus of 2I cap minus 2j cap plus 4k cap. Check whether these are coplanar or not. How do we do that? By finding the STP. If the STP is 0, then they are coplanar. Okay, so for STP, minus 2, 4, minus 2, 4, minus 2, minus 2, minus 2, minus 2, 4. Taking the basically, that is 0, then it will be, these three vectors will be coplanar. Let's find out minus 2 into minus 2 into 4 minus 8 minus 4 minus 4 into 16 minus 4. This is a lot confusing. You have to keep your brain active. So this will be minus 12 into minus 2 plus 24. 12 into minus 4 minus 48 minus 12 into minus 2 plus 24. So 48 minus 48 makes it 0. Hence, these vectors are coplanar because their STP is 0. So this is about STP, scalar triple product, also known as box product. Now let's discuss about the vector triple product. So product of three vectors, but the result this time will be vector quantity. Earlier, this was the case. But this time, there will not be dot here. There will be cross. This is the vector triple product. And its expansion is A dot C into B vector minus A vector dot B vector to C vector. So I should write bracket with this A dot C, A dot B. See, this is a scalar. This is vector. So this will whole become vector. This is scalar, this is vector, whole become vector, vector minus vector, whole become vector. Okay. Trick to remember. We are going from far to close. So first we will write A dot C. A dot C. Far. Okay, far. And then whatever is remaining. Then minus and then close. Then we'll go to the close. So this is how I remembered. You can also use this technique to memorize the formula. Or you may also learn it using that first I'll write B vector here and then write C vector and the dot product of the remaining two. This can also be one trick. You do it as you are comfortable. So this is how we have to find out the vector triple product. As we know, vector product is not commutative. So B cross C cross A is equals to minus of A vector cross B vector C. That is vector triple product. This much only. Any doubts?
No, sir.
Okay. So there are some important notes that I have written in my notebook when I was preparing. And that is basically just directly from the previous year questions. Some notes from the previous year questions. First, if A vector plus B vector plus C vector is given as zero vector, then A vector, B vector, and C vector are coplanar. Also, A cross B will be equal to B vector cross C vector, C vector cross A vector. These are the direct results. Any difficulty in understanding this? No? Yes?
No, sir.
Coplanar vectors are those vectors which lie on the same plane. Second, if there are two vectors given and we have to find the internal bisector vector, internal bisector angle. And how do we find out? Say this is A vector and this is B vector, and we are calling the internal bisector angle as vector as C. So it will be given by C vector is equals to lambda, which is a scalar quantity here, into the unit vector of A. I should write unit vectors only. So A vectors unit vector plus B vectors unit vector. Simply. Where C here, C is the internal angle bisector of A vector and B vector. Means this angle are equal. Any doubts?
No, sir. Clear, sir.
Okay. Next point. If it is given P plus Q plus R vector, lambda, and let me use another scalar here, mu. These are scalars here, are given as zero vector. Lambda and mu are scalars, natural numbers. Then P, Q, and R vector are collinear, as we have talked about two vectors being collinear this way. This is the way for three vectors to be collinear. Next is about a parallelogram. Do the diagonals. Let's name it A, B, C, D. And this point is P. So I'm calling the position vectors, like if O is the origin somewhere here, O is the origin. So OA vector is a position vector of A, which I'm calling as A vector, OP vector as B vector, and similarly OC as C vector, OD as D vector, and OP as P vector. So just for the simplification. So here, one thing is to understand is this, that 2P vector is equals to A vector plus C vector, also equals to B vector plus D vector. Why? Because the diagonals of parallelogram bisect each other. I just cross, wait a minute. Yeah, so 2P is equals to A vector plus C vector. So this can also be written as P vector is equals to A vector plus C vector divided by 2. Why? Because the diagonals of parallelogram bisect each other. Bisect each other means this part is equals to this part. Basically, P point is the midpoint of BT. P point is the midpoint of BT. So P vector is equals to B vector plus D vector by 2. P vector, B vector plus D by 2, because it's the midpoint. And it's the midpoint of A and C as well. So A vector plus C vector divided by 2 as well. So this is how we can write. Any doubts? This is a previous year question, literally.
No, sir, no doubts.
No doubts. So there's one last point remaining. Sometimes you will be given vertices of a triangle. Let's say, should I construct the example or should I take it from the book? Anyways, leave it. So sometimes you will be given vertices. Let me construct an example here. like this. And not just two vertices, of course, there will be three Cartesian system, 3D. So 1, maybe 0, it may be 3, like this. So what you need to do is you have to make vectors for then and there. How you can do so? By, let's consider this as point A, point B, point C. So find EB vector by subtracting like 1 minus 0 I cap plus 1 minus 0 j cap plus 3 minus 1 k cap. That is AB vector. What about BC vector? So subtract CE coordinate first, 2 minus 1 j I cap plus 2 minus 1 j cap plus 0 minus 3 k cap. This is BC vector. CA vector, so 0 minus 2 I cap plus 0 minus 2 j cap plus 1 minus 0 k cap. This is how you have all three vectors, but we need only two vectors. So just find two vectors and go ahead with this formula for finding out the area of triangle. Any doubts? Any doubts in understanding? Yes or no?
No, sir.
Okay. Then shall we solve some previous year questions now?
Yes, sir.
Give me a moment. See, this question just we have discussed. ABCD is a parallelogram. ABCD is a parallelogram where P is the point of intersection of the diagonals. O is the origin. OA plus OB plus OCD. Basically, A vector plus B vector plus C vector plus D vector. It is what we have, what is asked for. And we have to tell it in the terms of P vector. So we knew that A vector plus B vector, actually no, not B vector, A vector plus C vector divided by 2 is P vector. So A plus C vector is 2p. Similarly, B vector plus D vector is 2p. So if we add both of these equations, answer comes out as A, 4 OP vectors. Is this clear? Say yes or no.
Yes, sir.
Okay. Next question. If B and C are the position vectors of the points B and C, respectively, within the position vector of point D, such that BD. Okay. So point B and C, and BD is equals to 4 of BC. So BD must be lying somewhat out. So yeah. So BD is equals to 4 of BC. ठीक है. So BD vector can be written as if I consider D as D is having a D vector, it is given that B, it is given as C. So similarly, BD can be written as D minus of B vector is equals to 4 of BC. BC vector can be written as C minus of B. Let's solve it. D vector will be 4C vector minus 4B vector plus B vector. So it will become 4C vector minus of 3B vector, making C as our correct option. 153, right? So let me check the answers. 153. C. Yes, C is our correct option. Is this clear?
Clear, sir.
Let's discuss about the 154th question. If the position vector A of the point is such that then the value of n, okay, position vector is 5 is to n, and the magnitude is 13. So we know 13 is equals to square root of 5 minus 0, 25. 5 minus 0 whole square 25 plus n minus 0 whole square n square. It should be equals to 13. Taking square on both sides, 169 is equals to 25 plus n square. So 169 minus 25 is equals to n square, which is actually 144 is equals to n square. So taking square root, n becomes plus minus 12. Option number B, 154B. 154B is the correct option. Yes, 154B is the correct option. Is this clear? Any doubts?
No, sir.
Next question. Magnitude of A, magnitude of B is given. We have to find out this. So this is actually magnitude of A whole square, magnitude of B whole square, sine square theta plus dot product. So magnitude A whole square, B magnitude whole square into cos square theta. So what is common is the magnitude whole squares. So which is actually given to us also. The remaining is sine square theta plus cos square theta. 4 into 9 is 36. What is sine square theta into cos square theta? Sorry, sine square theta plus cos square theta is what? 1. 36 into 1 becomes 36 only. So 155. D is the correct option. Yes, D is the correct option. Any doubts?
No doubt, sir.
Okay, let's discuss this question. Let A be two unit vectors, theta be the angle between them. So we have to find out the cos theta of y2. First, cos theta will be, if there are unit vectors, so first we'll consider their dot product divided by their magnitudes. Magnitude will be 1 because of unit vector. So that becomes 1. Dot product. So the dot product will be written here. That is cosine of theta. Okay. In the options, we can smartly see there is some addition or subtraction. So let's find out the addition. So A plus B unit vector, its addition whole square will be as square plus, अरे यार क्या भूल गया. Is the screen visible properly?
Yes, sir.
Okay. So let's move ahead. Now plus 2ab into cos theta. We know that the magnitude is 1 only. So left hand side, magnitude is 1 only, na? 1 plus 1 plus 2 to cos theta. That becomes 2 into 1 plus cos theta. Okay, 1 plus cos theta is what? It's 2 into cos square of theta by 2, which is a plus b magnitude whole square. This is 4, and this is cos square of theta. This is square also. So we can take a square root. On taking square root, this becomes a plus b is equals to 4 becomes 2. Cos square theta by 2 becomes cos theta by 2. This is what we needed to find out. So this becomes divided by 2. Let's look in the options. For the options. So our correct option should be where it is. Our correct option should be B. Correct option should be B. And let me check for the answer. 160B. Yes, 160B is the correct option. Any questions? Is this clear or not?
Clear, sir.
Okay. So as we have found it out cos theta by 2, it is very easy to find out sin theta by 2 just by 1 minus 1 minus cos square theta by 2 whole square. Okay. Shall we conclude the class? Any doubts?
No, sir, no doubts.